First, remember last time one student asked a question about the regular expression. So let me answer that question first. All right. Do experiment. So I already started, the server here. So let me run the. Here I use this company database. Here's the employee table. In this table, too small, right? Let me see. Can I make it larger? Yeah, good. I can make it a little larger. Yeah. All right. Now, to test a special symbol, you can see I insert a $ in this address. This one. Okay. Yeah. So the original data, no $. But in order to test the special symbol, so I insert this $. All right. Then let us do some experiment first. Yeah. Employee address. Regular expression. All right. Yeah. So let's use several different ways to see, compare the difference. The first one, we want to catch that $. Yeah. We know it's a special symbol, right? Double slash, backslash, then $. Yeah. So that's the command. Okay. All right. Yeah. So that semicolon actually not important, right? Yeah. With or with, yeah. With. If you have multiple statements, then it's important. Yeah. All right. Go. Now you see that line containing that $. Is selected. Yeah. So it works. Yeah. All right. Then the answer the grand question. If the $sign is inside a pair of brackets, so that's the question he asked last time. Yeah. All right. So this time. Address, regular expression. This time, let's look at when we use brackets. We only use $sign. Okay. And because when we use a $sign inside brackets, do we still need to use that double backslash? Yeah. So here, okay. Yeah. If you use double backslash, it's okay. Yeah. But let's remove the double backslash. Yeah. You can see it works. So that means the $sign inside that pair of brackets, we do not use the special meaning. Or in other words, that pair of brackets can be used as escape. Escape meaning. Yeah. Similarly, because we know the dot symbol is special one, right? Yeah. Similarly, let's check it, because not just the $sign, dot. If you're putting a pair of brackets, you do not need double backslash. Yeah. There is a line containing dot. Okay, this line, the street, st dot. Yeah. So let's try to match this one. Yeah. The address that contains a dot. Contains a dot. Yeah. We know if you use double backslash, it's okay. But let's put in a pair of brackets. Yeah. All right? Yeah. Look at the if. brackets here place that escape. See, yeah. So we won't use the special meaning of that dot. Dot has a special meaning. Yeah. All right. Yeah. So in this way, so when you use the regular expressions, so you can see the difference. Yeah, see the difference. Yeah. But if you use double backslash, it's not wrong. Okay. Yeah. Inside brackets. It's not wrong, but it's like a redundant. Yeah, it's redundant. But later, you will see sometimes when we do something redundant, there is some reason. Many people, they like to do something redundant. Yeah, the reason is for readability. Although something it's not necessary, so you can remove it. Yeah. But some people, based on their long time experience, so they like to type a little more things to improve the readability of the whole statement. Yeah. That happens. That happens. Yeah. Later we will have several cases. Yeah. So even we know. When you do something, it's redundant, but there is some special reason. People do it that way, yeah, just for readability. Yeah. For example, this kind of double backslash, if you use inside a pair of brackets, that's redundant. But some people may like to still, they know it's redundant, but some people may still like to use that because they want to emphasize. So this is a literal symbol. Okay, it's a literal symbol. They want to emphasize it. Okay, improve the readability. Yeah. Otherwise, you have one pattern. You contain dots several different places. Which one is the literal? Which one is the special? Right? Yeah. So when you have the situation like that, then people may like to, emphasize. If it's a literal, then they use double backslash. If it's a special symbol, then they do not use the double backslash. In that way, to improve the readability. Yeah, so that's another, method many people commonly use that way. Readability consideration. Yeah. All right, so that's that question. Yeah. All right. Next, let's move to new module, module 3 first, part A. Yeah. Here. Okay. Yeah. SQL basics. So this whole module we want to study the basic concepts, some basic rules, SQL basics. Yeah. Yeah. All right. Part A, understand SQL structure. All right. 8.1, database schema. The schema concept. Yeah. The basic concept. Yeah. All right. The meaning of schema first. Yeah. So we also need to look at the history, because this concept evolves. The early time meaning of schema is different from the current meaning. Yeah. All right. Its meaning, description of a database. That's simple. Yeah. Definition, description. How do you describe a database? You use SQL statements to define all the constructs in your database. Yeah. So that's description over there. That's what we call the schema. Yeah. But so here, let me remember. When I when I give you a database, how do I give you a database? So when I ask you to download a database, I upload a database script, right? Yeah. So I upload a text file. So that's the database name .sql. Yeah. So the script, database script file. Yeah. So it's a text file, all right, containing all the SQL commands that you use to populate the whole database. Yeah. All right. So in that database script, so in a database script, okay, yeah, contains two parts. Okay, yeah. The definition part, definition of the database. Then, second part, data of the database. This data part, usually we use the insert statement. Insert statement. Statements. Okay? There are many insert statements. Insert data. Yeah. Yeah. So that part, that's the data part. Yeah. And this part is the schema part, the definition part. Yeah. In other words, the schema part does not contain the data part. Okay? Yeah. So if people talk about schema, so you remove the data. Okay? Yeah. Only the definition part. All right. Specified during the database design. Yeah. So, all right. So when you design, right, statement by statement. Yeah. Not expected to change frequently. Yeah. So here, yeah, I need to explain. Yeah, because to explain this line, we need to look at the whole life cycle of a database. Yeah. Oh, yeah. Yeah, we need to look at the life cycle of a database. Early stage, later stage, yeah. So that it's different. Yeah. Yeah, all right. So early stage. Early stage, then the schema changes frequently. Yeah, because that's early stage, design stage. So you can think about that. Yeah. Change frequently. Yeah. Because at early stage, the designers, the database designers, they need to understand the business, right? Yeah. So, because there is a business project. Yeah. So, the designers, they need to understand the business requirements. Yeah. And at the beginning, they may not understand the requirements well. Yeah. So, a lot of communications between the business people and database designers. Okay, a lot of meetings, discussions, to help database designers to understand business requirements. Then, so they come up with a plan, write the first version of database. Yeah. But it's a lot of things because the understanding is not very good at the beginning. So they need to improve the understanding. They need to do more and more communications. Yeah. So these two groups of people, they need a lot of communications to get better and better understanding of the business requirements. So when they get a better understanding, they need to improve the database table structure, design, So they need to change the design a lot. Okay? Yeah. So that's very common. Yeah. 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 But at a later stage, then the structure becomes more and more stable. Yeah. Yeah. More and more stable. Yeah. So then this is correct. Okay. Yeah. 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 So there. Yeah. But it's possible if it's necessary, because if there is some very important change in business requirements, then some tables, some parts, there some change has to be made. Yeah. But at that time, you need to think about when you change the database, certain tables, it becomes harder and harder. Okay, yeah, because after you have a lot of data, large amount of data, so when you make some change, it becomes harder and harder. Okay, yeah. So you need to consider when you change. People need to. So at sometime your customers rarely use the application. Yeah. Think about that situation. So when you make that change, you do a lot of testing. Yeah. So then at between 2 o'clock and 3 o'clock, and that time usually, so you do the change. Yeah. Yeah. Schema construct. Yeah. Yeah. First, the concept, entity concept. Yeah. When you define a table, there are two types of table. Yeah. So what information do you use to store in a table? Business object, right? Yeah. A table is used to represent business object. That's the most frequently used way for a table. Business object. But what's a business object? Okay? Yeah. Entity. Entity. Okay? Yeah. So the first table type, entity type table. There are two different types of tables. Yeah. The most popular one, the entity type table. So student, employee, entity. Okay? Yeah. Business object. That's a business object. Entity. Okay? Yeah. Row in a table or record, the data. Yeah. So each row, each record, yeah. So that's the used to describe one instance of entity. Yeah. All right. Yeah. Represents a real world object, such as employee. Yeah. Yeah. But there is another type, although not as popular as the entity. Yeah. So the percentage of the second type much smaller than the first type, but also very important. Yeah. The first type, this entity type, approximately 90%, let's say, in that percentage, close to that percentage. The second type usually, about 10%, or even less than 10%. Yeah. But the second type also important. Yeah. Attribute. Yeah. Second type we will see later. Yeah. Attribute. Yeah. Yeah. Because for each entity, so each table when you describe a business object, yeah, you need to use, several attributes, to, you need to, in your business, you need to represent those aspects. All right. A column in a table or a field. So each column, one attribute. And this terminology, attribute terminology, so here, this entity, attribute, these terminology, so you will see. Remember, I mentioned when we talk about SQL, there are two versions SQL. Okay, so when we talk about SQL, two versions. One version, industry, business, industry, business. Another, academia. Okay, So then, in these two environments, people use different terminology. These concepts, formal concepts, that's used in that, academic environment. Okay. Entity, attribute, formal. But in business environment, so there, people use, this part, okay? Other part, table, row, record, a column, field. Many times mixed. You see mixed. But there are some reasons behind it. Okay. Represent some property of interest on an entity, such as employee's name. Then, the second type, so the entity type is the first type of table. Second type table, relation type table. That's different from entity. Okay? Relation, because we need to represent relation between two entities, two business objects. What is the relation between those two objects? So that's different from the entity. So it's not a business object. It's a relation of two business objects. So that type also important. We still use, so this is second type of table. But here I like to explain this relation type of table. All right. Let me give you a simple example. All right. Example about the relation type table. All right. Usually a relation, it's a mapping. Because you do a mapping between two business objects. So you want to describe mappings between two business objects. Okay? Here, let me give you a simple example. All right. So from this example, you can see if we only have entities table in a database, it's not enough. So we need this kind of relation type of table. So let me describe a project. So for our this university business. Okay. So we need to do some exercise, for example, for let's say we need to let's say a professor needs to create assignments. Okay, create assignments. You know, develop a business application that allow professors to create math assignments. Yeah, let's say it this way. Okay, math assignments. All right. Yeah. So, in this kind of application, so you need a table to store math problems, right? Math questions. Math questions. Okay, math problems. Let's say one table. Let's say problems. Yeah. Yeah. But another, because all these problems, in order to create good assignments. Yeah. So the professors, they like to put these problems in different categories. Yeah, different categories. Yeah. So you need to have category table, right? Yeah. So another table called a category. Category table, right? Yeah. That. What's the relationship between problems and the categories? Okay. Yeah. So let's look. The category could be number theory, one category, right? Calculus, another category, right? Differential equation, another category. So you have many different categories. Okay. Yeah. So you organize. So you need to create a mapping between each math problem and one of the categories, right? Yeah. So that kind of relation, it's a mapping. Yeah. That is a mapping. Okay. Yeah. Mapping between these two business objects. These two business objects. Okay. Yeah. So there are some of the tables you need to store the mapping information. Yeah, so that's not a business object, right? Yeah. So we call it these tables relation type tables. Yeah. But regarding the relation type, there at the database design stage, at the database design stage, database designers, they use some productivity software to do the database design. They draw diagrams. Yeah. So some software tool can help those designers to draw, different diagrams, the relationship, so they can understand the structure of the database better. Yeah. Yeah. That kind of software. If you use that kind of software to design a database, when you design a relation type table, you need to specify. You need to, because you want to consider what kind of relation is used between these two tables. There are several different types. Yeah. For example, for each problem in the first table, do you allow one problem map it to multiple categories? Yeah. One math problem. Can you assign one particular math problem to several different categories? Number theory, calculus, geometry, right? Things like that. Yeah. Yes. One problem, because you may use knowledge from several different categories, right? It's possible, right? Because you use, knowledge from several categories. Yeah. So that one you need to address. Yeah. Another kind of relationship you also need to consider. Yeah. For each category, yeah, definitely there are many problems belong to the same one category, right? So each category, yeah. So this kind of relation people call the M to M. Yeah. M dash to N. Okay? Yeah. There are many different type of relation. Yeah, let me list. 1 to m. Yeah. 1 to m. Yeah. M to 1. Okay. M to 1. Yeah. And 1 to 1. Okay. Yeah. 1 to 1. Yeah. So that's the, all the possible relationships. Yeah. Yeah. But m to 1, it's rare. Okay. Yeah. 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 It's possible. Yeah. Yeah. It's possible. Yeah. For example, you do not allow, one problem to be assigned to multiple categories. So that's m to 1, right? Yeah. Yeah. It's possible. Yeah. Yeah. So there are total these 4 types of relations. Yeah. But when you design it, you need to specify which type. Yeah. Is it m to m, right? The diagram, draw m to n. Yeah. Yeah. Things like that. Okay. Yeah. So in that way, yeah. So you understand the structure of your database better. Yeah. This kind of relationship. Yeah. So yeah. When we do practice, yeah. Yeah. Actually, yeah. Let me think about. Yeah. Because many students, based on my previous experience, many students, they are not quite familiar with this relation type. Okay, so they can use the entity type tables well in the web applications, but when I ask them to develop some feature related to the relation type table, yeah, so then they have many questions. Okay. So how do you store this way, that way? Okay, many different ways. Yeah. So that kind of experience, yeah, also very important. Yeah. So let me think about. Yeah. So in my second project, I tried to add one relation table, okay, for you to do practice. Yeah. Because entity table very easy. Yeah. It's straightforward. Yeah. The understanding is straightforward. But relation type, yeah. So then, a lot of questions. You need to get used to it. Yeah. All right. Yeah. Table types. Yeah. So here I already talked about that. Okay. Yeah. So I can do a little faster. Yeah. The relationship. Yeah. Yeah. In that one, actually, so if some of you learn the graph theory, yeah. So these 2 types actually related to the graph theory. What is a graph? Right? Vertices and edges. Here you can see vertices corresponds to entity. Yeah. Each entity corresponds to one vertex in a graph. Yeah. Edge relationship. Okay. So when you draw a graph, so you need to have certain number of vertices. Then, what's the relationship? Yeah. So you need to draw edges, right? So those edges, yeah, that's because that's a relation between 2 vertices. Yeah. So that's a graph model, for our table. Yeah. Okay. Yeah. All right. Examples. Yeah. In this first example is from our company table. Company database. In the company database, we have 6 tables. We have 6 tables. Yeah. 5 of them, 5 of 6 entity tables. Entity type. Yeah. The last one, that's the relation type. That is the name is called works on. Yeah. Works underscore on. Okay. The works on table. Yeah. Yeah. Each employee. Yeah. Because you need to start. Each employee needs to work on certain number of projects, how do you store that information? Okay? How do you store, all the information for your employees work on all the projects? That's mapping, right? Works on mapping, okay? And you can see it's an end-to-end mapping, right? Works on, yeah? Because one employee can work on multiple projects. And each project, you have multiple employees to work on, right? Yeah. So here you can see, yeah. So that works on M to M type relation. Yeah. Okay. Yeah. All right. Another one, math problem relation between math problem and category. Yeah, I already explained in the previous slide. Yeah. Yeah. So here you can see, in the real-world applications, there are many situations you need to use the relation type table to, implement certain features. Yeah. 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 All right. M-to-M mapping. Yeah. All right. That history of schema. The early time. Let's look at early time. The meaning of the schema. At the beginning, early version of SQL did not include the concept of a relational database schema. Yeah. So early time. Yeah. So the structure was very bad, the early time structure. So what's that structure early time? Yeah. So you can see all tables were considered part of the same schema. So what's that? All right. Suppose you have multiple business projects. So we know usually for different business projects, the databases should be different, right? Yeah. Different business objectives. Yeah. So the database should be different. But at that early version of SQL, no matter all your business projects, all the tables for all those projects, you put them together, okay? Not separated. Not separated. Or you can understand all the tables from all different projects mixed together. Yeah, not separated. Okay? Yeah. So that's the early version. Yeah. So then you don't have that schema concept, or the schema containing all tables. That's the schema. Okay? Yeah, that version. Yeah. But definitely, so people feel if you do not separate, then it's very hard to manage different business projects. When you have multiple projects, then all the tables not separated together, you get confused, right? So those tables, which project? So you get confused. Yeah. So then, the second version, SQL 2 version, second version of that SQL, then the schema concept was created to separate tables for different business projects. Yeah. Okay. All right. So group together tables and other constructs, the other domain constraints, other constructs. Yeah. Store the procedures. All other constructs. Okay. Yeah. That belong to the same database application under the same schema. Then, that's the current version, okay? Yeah, separated. Yeah. So different databases, they use different schemas. Yeah. Yeah. So one database corresponds to one schema. Yeah. So under that schema, you have you have certain number of tables. Yeah. But for different databases, although the tables may have the same name, but completely separate for different databases. Yeah. All right. Yeah. So that's the concept. Next, 8.2 database languages. You know, we go back to the academic project, yeah, because when the SQL was designed, first in the academic project, then several different languages was used to, work for the data for different purposes. Yeah. All right, database languages. Yeah. The first type, data definition language. Yeah. We use DDL, data definition. You need to define data format, right? So data definition language, DDL. Okay. Yeah. Yeah. So here, yeah. Here I go back to the history a little bit. The history of the SQL. Okay. History of the SQL. Yeah. So at that time, first, those researchers. So here we go back to the academic project. So those researchers, so they need to create a special language called a data definition language, to allow users to define the data format. Yeah. So that's DDL. Was created. Okay, define schema. Yes. Yeah. Schema. Yeah. So you define, so everything is one special type of language. Then, when you use the data, you need to view the data, right? So view definition language. So another type of language should be created. So VDL. View the definition. Okay? You want to view. Okay? View the definition. So VDL language was created, right? The second type. Yeah. Then, specify user views. Yeah. All right. Then, data manipulation language, DML. Yeah. So then you need to manipulate the data, right? Yeah. All right. So include retrieval, insertion, deletion, modification. Yeah. So that's our, in current SQL. So we know, the data manipulation language, another type of language, in that, early time academic project, okay, about SQL. Yeah. All right. Yeah. So so many different languages need to be used in that project. Yeah. All right. Then, at the end, so they just design a big, higher level, comprehensive, integrated language containing all of them. Okay. Yeah. So because you do not need to separate those three different types of languages, right? Yeah. So SQL contains all of them, because it's not necessary to separate them. All right? Yeah. But this DDL, so in some database articles, sometimes you can still see the authors use this DDL, in their articles, technical articles. Yeah. All right. Yeah. The second VDL, DML, rarely used. Yeah. Rarely used. But that DDL, still, you can see many times it is used. Yeah. All right. Yeah. Combination of all these three. Yeah. All right. Statements for the constraint specification, schema evolution. Yeah. That's SQL. All right. So evolution. So the SQL version. Yeah. So SQL version. Yeah, actually we know for every programming language, there is evolution, right? Different versions. Yeah, because for Java, you see different versions. For Python, you see different versions, right? For every programming language, version by version. Okay, yeah. Each version, you have some improvement. Yeah. The SQL relatively stable. Yeah. SQL, comparing with other programming language, the version change not very common. Okay, not very common. Yeah. But if we move to different DBMSs, then that's different. Okay, yeah. So SQL quite stable. SQL, very stable. Okay, yeah. But when you move to, so we know. So here, SQL, this programming language very stable. But we know the SQL, remember, for DBM, SQL, so then we look at the SQL under different DBMSs, then there are many different versions. So remember, because SQL we know, because the SQL we know there are core part, right? Two parts, core part and extension part. Two parts, core part, extension. Core part very stable, okay? Yes, this stable. But extension part not stable, okay? Yeah, many versions. Many versions, yeah. And just like the usual programming languages, yeah. So the features for different versions, a lot of changes. Yeah. All right. Yeah. And so for our class, actually you will see two versions. Yeah. Remember, many of our exercise questions, I ask you to use the W3 School, so that tool to help you, study W3Schools.com. Yeah. W3 Schools, so there is a My SQL section, okay, yeah. But that section, that one where you use, remember, it's an older version, okay, yeah. So it's a version 5. Version 5, it's an older version. And our version, our current version, so exam, I ask you to install exam. See, the version is so different. Yeah. Then later there is an important feature. Yeah. So in our complex query part, I need to introduce a very powerful, important feature. But that feature is not available in version 5, but it's available in version 8. Okay, version 5, it's that feature is not supported, but in our version 8, it is supported. Okay.
So is the exam version 8 or is that version 8 of MySQL?
MySQL, okay. Exam in the current version. Yeah. Current version, not necessarily. But current version that MySQL contain inside it is version 8. MySQL version 8. Yeah. So this is a MySQL version 8. That lot of differences, okay? A lot of differences, yeah. Because still, many older versions of MySQL still used in many different places, due to the business cost, right? Yeah. So many companies, if they need to change from older version to there is a cost consideration. Yeah. They need to consider the switch. Yeah. How much cost it is, right? Yeah. So it's not that easy. Not like us. We change from one version to another version. So that's very easy. But when the big company, when they change from one version to another, it's a lot of related costs they need to consider. They're very expensive. Yeah. So that's why they do not change that frequently. This version 5, still used in that server. Okay? Yeah. All right. Yeah. So let's next topic. Properties of SQL. Yeah. Some basic properties of the SQL. Yeah. First, it is a standard language for commercial relational DBMS. Yeah. Yeah. All right. SQL standard, all those things. But for us, we know more, right? So although, we know more, because the core part is standard, right? Yeah. The expansion part, so it's not a standard. Yeah. So we know more. Yeah. Not that, because if people do not know the details, so they may treat the whole SQL, all the features, so that it's not that. Yeah. All right. It is a comprehensive database language. Yeah. Yeah. How comprehensive? So we learned that, right? Containing those 3 types, that kind of comprehensive meaning. Yeah. Yeah. So here, yeah. And VDL. So here it does not mention that VDL. Yeah. Whatever. Yeah. It has facilities for defining views on the databases, specify security authorization. Yeah. Yeah. So grant permission, privilege. Yeah. Yeah. Because for different users, so you need to, assign certain privileges, right? Some tables, some users are not allowed to access. Yeah. 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 So that, in a big company, you can imagine that. In a big company, so the users with different roles, so they have different privileges to access different tables. Yeah. So when you write your code, you need to keep that in your mind, right? Yeah. Different users, they have different privileges to access the different tables. Yeah. So that's a consideration. So when you write your SQL command. Yeah. All right. Yeah. Defining integrity constraints. Yeah. Yeah. A lot of integrity constraints. Yeah. Define. Yeah. Yeah. DBMS has some built-in support. Yeah. But the built-in support usually for relatively simple integrity constraints. Yeah. But for complex business constraints, then we need to write a stored procedure. Yeah. All right. Then specifying transaction controls. Yeah. All right, transaction. Yeah. All right. So I explained that advanced feature before. Yeah. And to give you some basic information. Yeah. All right. Yeah. Rules for embedding SQL statements into a general purpose. Yeah. So here, yeah. At this time, this one. Yeah. Let me see. Yeah. I only have 10-something minutes left. Yeah. Here, yeah, let me just explain this last point. Use the remaining 10-something minutes. Yeah. Because the question about this point, there is a very important, technology consideration. Yeah. So I want to explain here rules for embedding SQL statements. Yeah. So when you use the general programming language, okay, yeah, Java, PHP here, okay? Java, PHP, and other programming language. Yeah. All right. So when you embed, so there, the rules could be different. So here I use Java and PHP to do comparison. Yeah. So, all right. So in Java, Java way, right? Java way with interfaces. But interfaces, there are two types of interfaces. The first type for vendors, okay? Vendors. So for MySQL, Oracle, yeah, Microsoft, SQL Server, right? So those DBMS products, the vendors for those products, so Java provide one set of interfaces for the DBMS developers. So they need to implement those interfaces to handle the communication between programmers and the DBMS. Okay, all right. Then the second set of interfaces, so for programmers. For us, yeah. When we write Java programs to do the database queries, we need to use the second set of interfaces. Okay, second set of interfaces when we write a code. Okay, all right. So this is the Java way to handle the database communication. So the difference is this one is, okay, the result is, yeah, the same interfaces for all different DBMSs. Yeah. So when you change DBMS from, let's say, from MySQL to Oracle, you do not change the interfaces, okay? You use the same interfaces. Yeah. Yeah. All right? Yeah. So here, let's consider DBMS change. DBMS change. Mess. Now, what do you need to change in Java? Here, let's talk about in Java. Okay, the change. Yeah. You need to change database DB. Here I use DB database drivers. Driver. So it's a library file. Okay, yeah. Drivers is a library file. Yeah. You need to download library file. Okay, download. Yeah. MySQL, you need to download the MySQL version library drivers file. Okay. Oracle, you need to download Oracle version of library drivers file, and so on. For each DBMS, you need to download the corresponding drivers file. The drivers file provided by a vendor, okay? The drivers file provided by the vendors, and the vendors use the interfaces provided from Java to develop the drivers file, okay? So for the bottom level communication, tedious work, okay? Yeah, so that's in the driver. So you need to change the driver, okay? Other than the driver, you need to change the URLs, right? Yeah, because for different databases, the URLs could be different, right? The URL, the format, the name, the port number could be different, right? So port number inside of that URL, okay? The protocol could be different, right? The port number could be different, right? The domain name, all other things, yeah. So URL you need to change, all right? Yeah. So other than this account information, right? Yeah, you also need to change account info. Yeah. Account info. So that's the thing you need to change in Java. Yeah. But the business logical you don't need to change. Okay? So all the other, the class name, the method name, all those things you don't need to change. Yeah. Yeah. So then another important change, the SQL statements. SQL statements. Remember the SQL statements, because that extension part, right? Due to that extension part, you need to make the change, right? If the SQL statement using the core part, then you do not need to change. But you do not know, right? Yeah, sometimes some special features, for example, that limit, right? I give you an example. In MySQL, that limit keyword, from MySQL to Oracle, then you need to change. You need to find a different way to do it. Yeah. Okay? So the SQL statement, that's the hardest part. Yeah. The right way to write the SQL statement. You need to do testing, all right? You need to do testing one by one. The SQL command. Yeah. So that's the change. But for PHP, I have just last 4 or 5 minutes. For PHP, then the whole method is completely different. Yeah. So here, let me explain the PHP way here. Okay. Yeah. PHP way, no special interfaces used. Okay. Yeah. So different from Java. PHP way, no interfaces used. Okay. All right. PHP provide different sets of functions for different DBMSs. Okay? Yeah. For example, for MySQL, if you want to do queries in MySQL, you need to use the MySQL version functions. Yeah. So the function, you have a MySQL underscore something. Yeah. So the function name, from the function name, you can see which DBMS. Yeah. When you switch to Oracle or other DBMS, then you need to use a different set of PHP functions. Okay? Yeah. It's different from Java. Java uses the same set of functions, classes, methods, because they use interfaces. Okay? Yeah. The reason why Java can use the same set of functions, because they use some common interfaces. Yeah. Then, because how do you address the different properties for different DBMS? Then different database drivers take care of the differences for different DBMSs. Okay? Yeah? So Java used that smart way. So they feel, so that's the smart way. So so in their, JDBC technology. So this is the Java JDBC technology. Okay? Yeah. Java database connectivity, JDBC technology. Yeah. But in PHP, in our programming language, they do not use this way. Okay, they just whenever you have a DBMS, so you need, the PHP creator, developer, the PHP vendor, whatever, creator. So they need to, it's their responsibility to develop the appropriate version to cover that DBMS. Okay? Yeah. So that's the, two different ways. Yeah. So, yeah. All right. Yeah. So, let's stop right here. Yeah.